Hi everyone, thank you for joining once again to my channel NEGB. So today is a continuation topic in C++. We are going to look at application of array. Okay, if you haven't watched my video on arrays in C++, please go to my channel. This is my channel. I'm just going to write it down in case you don't know. So this is the name of my channel, and search for one-dimensional array. So before you watch this video, you need to watch one-dimensional array, two-dimensional array, and then input and output files. Okay, you need to know these three basic, not so basic, but these three topic first before we look into this application of array. Okay, so array involve static memory allocation, such as allocation of memory for a data variables when the computer program starts. This type of allocation is applied to only global variable, file scope variable, and also those variables that are declared static. Okay, there's another one called dynamic memory allocation. So in this way, arrays, only active arrays are allocated. Okay, for dynamic memory allocation, only active arrays are allocated. Some of the tasks lead to the need to determine the amount of memory in runtime. For example, this is the simple task. Okay, we ask the user to enter the number of elements. So every time you have cin, okay, so this requires dynamic memory allocation. So take input from user, again you cin, and then display all the entered element. Okay, this requires dynamic memory allocation. So in this case, the program doesn't know how many elements will be entered by the user before execution. The program must allocate memory for input during runtime after user input number of elements. In C++, memory in C++ is allocated by using operator new and delete. They perform the task of allocating by freeing the memory in the better and easier way. The new operator, if you see in your code, you see something like new, denotes a request for memory allocation on the free store. If sufficient memory is available, new operator initialize the memory and return the address to the newly allocated and initialize memory to the pointer variable. So what this all means? Let's look at what is pointer first. Pointer is often used when allocating memory dynamically together with a new operator. A normal pointer to an integer is declared by using single asterisk. Okay, this notation here. For example, we have int asterisk ptr, where a pointer, this is what you mean by the pointer. Okay, a pointer to an int integer is declared by using 2. If you have a pointer to pointer, then you use 2 asterisk. Okay, pointer to pointer have few uses. The most common use is to dynamically allocate an array of pointer with new operator. Okay, why this is very important? Okay, so in here we can say that we want to allocate an array to a new operator. Okay, so we can write something like this. Okay, dynamically allocating a two-dimensional array. This is two-dimension. If you look at that, with two-dimension compared to this one-dimensional array here. Okay, we can write something like this. We have this is a pointer because we have the symbol here. Okay, so what it mean? So memory that has been allocated by a call to new can be released using the delete operator. Okay, so once you allocate this memory, it's gonna start to free up some of the memory. Okay, and then you can allocate, releasing some of by using this delete pointer. Okay, the operand PTR addresses the memory space to be released. If you do not call delete, the dynamically allocated memory space is not released until the program terminates. So it's very important to allocate the memory. Okay, it's very important. So let's look at one-dimensional first. Maybe you are still not so clear about what this pointing array means, what it do. Okay, so let me just explain to you by showing you some example first. Okay, memory allocation for one-dimensional array. Let's look at one-dimensional array first. Memory for one-dimensional array is allocated dynamically as a pointer using new directive. Okay, once the array is no longer needed, it can be destroyed through delete, and this directive free the memory. Okay, so let's look at this. For example, the array A below is allocated with a maximum n+1 element, but memory is assigned to 3 variables which are active only as follows. Okay, so you declare this array A n+1. So once you do this, is called static memory allocation. Now dynamically, what happened here, we assign a single pointer to the variable A. So we have a pointer here, and then we have A equals to new int n+1, and we can put more code here, and then you have delete A. So this part here is called dynamic memory allocation. Okay, so the symbol, the asterisk symbol here, is only 1. So this is where we use for one-dimensional array. Okay, now let's look at one example in C++. Okay, I'm just gonna show you simple code. So file, new project. So 32 console application, maybe we put it code 6A. Oh, there's another project same 6A, so I gotta change it to code 61. Okay, next, empty project, finish. Okay, what I want to show in this code. Okay, let's do this. So go to the source file here, add a new item, C++ file, code 61. Okay, so what I want to do here in this today's lesson is to how to show how to write dynamic memory allocation for one-dimensional array. Okay, let's start with include iOS stream, and then using namespace std. So I am using Microsoft Visual C++ 2010 Express, so just to let you know. Okay, so we have void main. So what I want to show you in this code, how to a very simple code, that is how to display numbers from 1 to 10. Okay, that's my main task here. Okay, now this is my main body. Okay, so dynamically allocate memory of size n. So what I do, I need to introduce a pointer. Okay, see here? So I have a pointer here called a, and then how to declare this a? We have new int with the dimension n. Okay, what is n? So I need to define my n here. Define n is 10. Okay, this is my integer a, and now this is where I dynamically allocate memory of size n. And then what happened here, I can have a loop. So we need a for loop for integer I equals to 0, I less than n, I plus plus. So less than equal, we start from 0. Okay, that's fine. So what I want to do here now, okay, let's see. No. Okay, so C out. Before C out, I'm gonna see this a I equals to I plus 1. Okay, or you can start from 1 to less than equal n. So, and then I want to print it out this one-dimensional array. Print the output. So how to print it out? So I'm gonna have from variable a from 0 here. Now to print it out, I can use something like this. For int I equals to 0, I less than n, I plus plus, std c out ai less than this one. Or I can also instead of writing that, I can actually do this. So maybe we don't have to worry about that. Okay, so this is where how the values are being printed out, and then deallocate memory. So I need to have delete. Yep. Okay, so this function here deallocate the memory. That's it. Okay, so this is how I dynamic memory allocation for one-dimensional array. So let's test it out. So it should produce a value of number from 1 to 10. Okay, so now what about two-dimensional array? How do you do that? So I'm going to show you. Open another project. Code 62. It's another project called 62. So maybe I'll put 61A. Empty project. Okay, source file, add a new item, C++, code 6261A, add. Okay, so in this code, what I want to show is how to memory. So how to dynamic memory allocation for 2-dimension array. Okay, so we have looked at the one-dimensional array memory allocation. So the process is quite similar. Okay, the process is quite similar. So we just want to know, how does the memory allocation for 2-dimension work? Okay, so to do that, we need to have we're going to look at the matrix multiplication. Okay, the matrix application. So to do that, let's have I'm going to write it here. We're going to look at matrix multiplication of 2 matrices using input file. Okay, so since I mentioned this input file, let me just recall on the previous video that I said you need to use fstream. Fstream here does is to write and read a file. Okay, so it's going to be a matrix multiplication of the 2 matrices. Okay, so to do that, let's just look at what are the matrix A. So we have matrix A, which is 2 by 3 by 3. Matrix B is 3 by 3. No, 4. I'm going to say 3 by 4. Okay, and then you're going to obtain, this is what you're going to find. You're going to get matrix C, which is A times B. So the size of matrix C will be 2 by 4. Okay, so first we need to have an input file. Okay, how to create an input file. So I've shown it in my previous video. To have this input file, we need to have ifstream IPF, something like that. Okay, let's go to file, new file. Okay, so go to this text file here, open. Okay, so let's put the matrix A as 3, 4, 5. Say it's a 2 by 3, so 2, 1, negative 3. This is matrix A, 2 by 3. Now matrix B is 3 by 4, so we have negative 1, 5, 2, negative 3, negative 2, 3, negative 1, 5, and then we have 4, 2, negative 2, negative 1. This is matrix B. Okay, so that's it. I think that's all we need. Matrix A and B, and I want to use save as. Okay, save. I should have a save as. Okay, yeah, save as. Inside this code, I can't remember what my code is. I think it's short code 61A. 61A. So I think so. It's code, yeah. Inside this code 61A, this text file called, what do you want to call? So matrices or okay, let's put matrices. Matrices. Okay, save it. Make sure it's in this code 61A. Okay, save. Okay, now let's do this. It's gonna take a while, but I hope we can do it. Okay, so we define. So first we have include iOS stream, and then we need to have include fstream. Okay, this is, I've said many times, this is because we are using the input file. Okay, this is to write or read a file, so we need that command. Okay, and then we have some variable here. Okay, so we have to define some of the n here. So I'm going to put my matrix M, the size, which is 2, and then I have defined my matrix N, which is 4. Okay, which is 4, and then I want to define matrix P for my C matrix, which I know the size is 3 by 3, so I'll have 3 here. And then you have using namespace std void main open and curly bracket, open bracket and curly bracket. Okay, so everything else will go inside this body. Okay, so I'm gonna declare an integer I, j, k, okay, and then as well as yeah, ijk, and then what I have here, I would like to dynamic memory allocation for this variable here. Because it's 2-dimension, I have this double asterisk. Okay, so this is my matrix A, matrix B, sorry, and then matrix C. Okay, so this is where this is to dynamic. Put a small letter, dynamic memory allocation. Now let me just tell you once again why we need to do this. So why we need to define this, why we need to define or do something like this called dynamic memory allocation. So we want to do this because sometimes our coding can require amount of memory. Okay, so if we do not dynamically allocate the memory, that means C++ don't know how much memory you needed. Okay, so dynamic memory is important. It's important when we want to, when we want to tell the computer how much memory that it's require. When we want to allocate the memory, and just so that C++ knows. Okay, C++ knows. Okay, so to use this dynamic memory allocation, we are going to use for two-dimensional array, we're going to use a double pointer. Okay, a double pointer. So let's start with defining what is A here. So A equals to new. Now what does this new means? Okay, I've told you earlier on, A equals to new. This new operator denotes a request for memory allocation on a free store. Okay, so if the sufficient memory is available, a new operator initialize the memory and return the address to the newly allocated and initialize memory to the pointer variable. So okay, that's why we need to use this new. Okay, so what's the new memory allocated that we want to have? So integer p plus 1. Okay, b equals to new. B equals to new int p plus 1. Put a space here. C equals to new int p plus 1. A lot of red sign I'm showing here because I didn't put this pointer here. Okay, so there you are. So now we have dynamically allocated the memory. Now let's go to display matrix A. So for matrix A we have for I equals to 1, I less than equal than P, and then we have I plus plus. Okay, so now this is what we happen here. So what is my AI? AI equals to new int p plus 1. Okay, what is BI? BI is new int p plus 1. And then what is CI? CI equals to new int p plus 1. Okay, there you go. So we have defined this new A, B, and C. Okay, so I need to have a curly bracket here and close curly bracket here. So let's the data matrix A. Okay, so now look at the if stream because we want to open the input file. If stream ifp. Now the name of this file is matrices.txt. Make sure the spellings is exactly the correct. Okay, so this is my matrix A. So display my cout. Matrix A is okay. So this is my matrix A. Okay, now to read the data. Okay, this is just going to come out the cout matrix A is. Okay, now how to read the data? So we know that it's M by matrix A. If you look at this is matrix A. It's a 2 by 3 matrix. 2 by 3 matrix A, right? So we need M and P, where M is for my row, P is for my column. Okay, so let's do the row first. For I equals to 1, I less than equal than M, I plus plus. Okay, this is row matrix A. Okay, and then we have a nested loop for J equals to 1, J less than equal than P. Okay, and then J plus plus. So this is my column matrix A. Okay, so what are these? So I need to open the file, right? So to read the file, so I have ifp A I J. Okay, this ifp here read the data at the input file. Okay, and then cout A I J. Okay, so we want to display the data. Let's /tab, and then that's it, I guess. So this /tab here, after each element, you're gonna have a space. Okay, so this code here will display matrix A. Okay, that's it. So cout ENDL. So closing the curly bracket for the row matrix A. Okay, now similarly we need to do for row matrix B. So I am going to be naughty here by copying this code. Okay, and then change it. Okay, maybe I'll just don't do that. Okay, so let's display them to this part here to do the matrix B. Okay, so this is where we do data matrix A, right? Okay, this is matrix B, so we don't have to recall the data anymore because the data can be read from this text file here. Okay, we just get to do this part. Okay, so cout ENDL. So we're gonna have matrix B is, okay, ENDL. So I am doing this one here. Okay, and just giving some space, a lot of space. So I'll have a line of space, n line, and then will produce me the matrix B. Okay, so for I equals to 1, I less than equal, okay, let's look at the size of matrix B is 3 by 4. 3 by 4, so my row will start with 3. So I need P here. P I plus plus. Okay, this is row B. Open curly bracket. Now to do the column. For j equals to 1, j less than equal than n, and then we have j plus plus because this is to do the column B. Okay, so I'm just gonna close the curly bracket. Now I have P to read the data for B I J. Okay, and then display the data B I J, and then don't forget to have /tab here. So every element you provide with the space. This is to display B matrix. Okay, this is to read the text file for B matrix. Okay, so close the bracket, and then we want to have some end of the line. Okay, so I think I need to close another bracket here. Okay, that's the part for my matrix B. Okay, once we have done this, we can close the, don't forget to close the text file, like it's done. Okay, so now what the next step is to do for matrix C. What is matrix C? Which is the multiplication of A and B. Okay, let's do that. We have cout. Let's have a new line, ENDL, and then we have matrix C is, okay, so I have E and end of the line. So to do matrix C, I need a nested loop. I equals to 1, I less than equal than M, and I plus plus. This is the row matrix C, and then open curly bracket. This is the matrix, the column. J equals to 1, J less than equal than N, J plus plus. Okay, this is the column matrix C. Okay, so now what we do here, we have a curly bracket, C I J equals to 0. So what we're doing, we want to initialize my C, and then for we need a new K equals to 1, K less than equal than P, K plus plus. Remember, the dimension of A and B are not the same. Okay, the dimension of A and B are not the same, so we need to have this K here. Cij equals to plus. Okay, you want to do the matrix multiplication, you need to plus every element, multiply BKJ. So if you are not sure, you need to watch my video on this matrix multiplication. Cij less than, not less than, this put a tab on every element. Okay, closing the bracket for this one. Okay, so since we have a pointer here, okay, since we have allocated memory here, don't forget to delete A, B, C. Okay, so that's the delete operator here. What it does, okay, the delete operator here means the memory allocated by a call to the new can be released. Okay, can be released by using the following command. Okay, if you do not call delete, if you don't have that, dynamically allocated memory space is not released until the program is terminated. Okay, so don't forget cin.get to pause the system before so that we get to see the output. Okay, I guess that's all. So if we have error, we'll check it out soon. So let's debug it to see how the outputs look like. Okay, great. So my matrix A is correct, matrix B is correct, matrix C somehow is not correct. I think I know why. So I should have a C out here. C out ENDL. Okay, I need to have a new line. Here. Okay, let's try it again. Okay, this is correct, but then the multiplication seems not correct. So I gotta check the multiplication, what happened at the C here. Okay, so let me just recheck. So I have my C out matrix A, and then for I equals to 1, I less than M, I plus plus. Okay, and then I have a curly bracket here. This is for my row matrix, this is for my column. I have this, and then I've initialized for my C, Ci J equals to 0. This is initialized for C, and then for K equals to 1, K less than equal than P, K plus plus. The dimension for my matrix C is 2 by 4, so I have 2, which is my M, and then 4 is my n. Okay, so 2 by 4. Okay, that's right. So I have my n. Okay, and now what happened? I'm going to define Cij plus equals to just to, that's okay. So I have Aij, oh, here you go, it's Aik. Aik multiply with Bkj. Okay, Aik multiply with Bkj. That will give me the size. This will give me the size 2 by 4. 2 by 4. Okay, so other than that, let's check. So it's okay if you get the wrong answer, you just study your code again and just find out where the error is. Okay, is this what it looks like? Okay, so I can check quickly. 3 times minus 1 is negative 3 plus negative 8, and then 20. That will give me 9. Okay, so that's it. So this is what would it look like. Okay, so this is your output should look like. So this is how you dynamically allocate the memory for two-dimensional matrix. Okay, in my case, maybe my problem is a bit complicated. Okay, because I'm using this text input file here. Okay, this is my matrix A. This is my matrix B. Okay, that's all you need. Okay, so I guess that's all for the example. I don't mind showing you one more example, but let's hold that for now. I'll talk to you again on my next video. Bye for now.